In the summer of 1962, final preparations were underway for the first U.S. attempt to reach Earth's nearest planetary neighbor. Venus provided the best chance for a spacecraft to reach its destination. The spacecraft, though, was not what JPL engineers had first planned on sending.
Mariner was to be a new design, really a second-generation spacecraft that was specifically designed to go to Mars and to Venus. But the design was not far enough along for it to be used for the Venus 62 opportunity. So we actually took a Ranger, we called them Mariner 1 and Mariner 2, the first two Mariner missions to Venus, but they were Ranger spacecraft. Not many people know that.
Mariner 1 blasted off the launch pad on July 22, 1962. At first, all went according to plan, as the Atlas rocket accelerated through Mach 1, 2, and 3. But then, the Atlas began fishtailing and veering off course.
We're not on trajectory.
This is range safety. Stand by.
That reads good.
Mariner was only seconds away from separating from the errant rocket when the range safety officer had no choice but to give the destruct command.
Destruct command. Repeat, destruct command.
This one apparently blew up.
Analysis showed that the cause of the rocket failure was a software error. A single misplaced symbol of code had resulted in the loss of the first U.S. spacecraft destined for another planet.
We was offset a little bit by our knowledge that we had another one to go. You know, maybe we could resurrect things here. And that, of course, we put all the energies into that.
With the software problem corrected, Mariner 2 lifted off and began its 3.5-month journey to Venus.
The Earth sensor, when we first turned it on up there and locked on the Earth, it was working fine, but it was working at a much lower level sensitivity than we had designed into it. As we got farther and farther away from Earth, we knew that if that sensitivity stayed like that, we wouldn't be able to stay on locked on the Earth all the way to the planet Venus.
As Mariner 2 raced away from Earth, the signal strength continued to lower. If the signal could not be boosted, all communications would soon cease. There would be no science return, only another mission failure.
And just a few days before it would have stopped being able to track, the signal strength jumped up to where we designed it. And we were able to do the rest of the mission just fine with that Earth tracker.
Another pressing issue was keeping Mariner 2 on a proper course.
Tuesday afternoon, it is decided to go ahead with the trajectory correction. Goldstone engineers send roll, pitch, and velocity commands to the spacecraft. The motor is fired and shuts off on time. Now we must wait. New tracking data will determine if the flight path has been corrected.
For 100 days, JPLers worked around the clock, steadying what was becoming an ever more troublesome spacecraft. One of the members of the team was a 22-year-old flight controller who was both a pioneer in exploring the planets and venturing into the male-dominated world of engineering.
I found myself not only involved in the planning of the operations, but the actual conduct of the operations. And before I knew it, I was 22, and I had been assigned as one of several flight controllers on Mariner 2. I was good at that work. I was good at operations work. I had a shift of my own, usually midnight to 8 in the morning. Women didn't have opportunities like that, and there were some number of people who were pretty sure that they shouldn't. That flight was probably the largest experience in growing up a young woman could have. I got through it and I was very proud of myself for getting through it. But from then on, everything seemed easier.
In December, Mariner 2 was closing in fast on Venus, but it was in a precarious state. Portions of the spacecraft were overheating. Several critical telemetry sensors had stopped working altogether. It was taking all the energy the solar panels could produce to keep the spacecraft functioning. On December 14th, Mariner 2 made its closest approach to Venus, flying by at a distance of 20,000 miles. In Pasadena, a steady stream of science data came pouring back as audible sounds throughout mission control. Scientists were elated, although most of the results were more confirmations than new discoveries. There was no onboard camera, so there were no pictures. There was also no sign of a magnetic field or a radiation belt like Earth's. For a planet considered Earth's twin for its size and near proximity, Venus revealed itself to be a hellish world filled with carbon dioxide, and where surface temperatures are hot enough to melt lead. If the science return was modest, the public reaction to the technical achievement was enormous. For the first time, the United States could point to its first in the race for space. It is a proud time for the U.S., Time magazine proclaimed. No achievement by a Russian cosmonaut or U.S. astronaut, no experiment made by any of the myriad other satellites that have been shot aloft has taught man nearly so much as the improbable voyage of Mariner 2. William Pickering found himself featured on the cover of Time. Pasadena honored the JPL director by naming him Grand Marshal of the Tournament of Roses Parade. NASA arranged for Pickering and his management team to meet John Kennedy at the White House. In the Oval Office, they presented the president with a model of the spacecraft. 20 days after passing Venus, Mariner 2 transmitted half an hour of telemetry and then went silent. Today, the spacecraft is a mute piece of metal that endlessly circles the sun. But inside the spacecraft's thermal blanket is a small American flag, secretly placed aboard against official wishes, as a patriotic act to honor the very first in space for the United States.